If everyone could please grab a seat and we will get started. Good morning, everyone. I'm Chris Rebelo. I am the Senior Director of Communications here at the Buck Institute. It is my extreme pleasure to welcome you to our kickoff event in our Live Long Better seminar series. Today, we talk about exercise. A couple quick housekeeping notes. If you haven't already done it, please put your phones on silent. And the fire marshal is also always happy when I point out the emergency exits, which are at the back of the room. So a question, how many of you are new to the Buck? Is this your first time here? Yes, that's so exciting. So we want to bring everybody up to speed on what happens here at the Buck. And rather than me going on and on about our wonderful science, I thought it made sense for you to hear from the people who actually make it happen. So Joran's in the tech booth. Can you play the video?
The Buck Institute is interested in understanding aging, not only to make us live longer, but to actually alleviate and suppress the development of diseases.
Chronic disease is the great health challenge of our time. Aging is the main driver of chronic disease. To eliminate chronic disease, we must harness the biology of aging so we can live healthy longer. The Buck Institute is the world's first research organization dedicated solely to the biology of aging. We work with the building blocks of biology to understand how we age.
The Buck is concentrating on really trying to go to the root of the problem, so understanding that we can sort of intervene really early.
The Buck Institute is probably the best place in the world to be working on aging because there's so many different aspects of aging that are being studied. It's key because no one lab can do it all.
Our scientific explorers are brilliant, curious, and committed.
The idea that you could actually develop drugs that slow down the aging process was really something that 20 or 30 years ago people thought this cannot be done. Not only can it be done, but we will do it.
The pieces are in place. And we are in a unique position to put them together. Our world is defined by paradigm shifts, created by scientific discoveries. The biology of aging is the next frontier.
We're working toward a world where healthcare is better. It's a world where if we can eradicate the aging component to disease, we're all going to live healthier and longer.
It's just an incredible vision that really will, surpass anything else that we've ever seen before.
We are inviting you to a future of aging without illness. It's happening today, and it's happening here. Join us.
Our story. So before I introduce today's speaker, I want to thank our sponsors. They are listed in our program. I also want to make sure you all have note cards. So if you want to ask a question, that's the way to do it. At some point, a volunteer will come around and collect those cards, and I'll ask those questions when I'm in conversation with Simon. So. Special welcome to those of you who are on Zoom. There's, I think, 400 people who signed up to join us on Zoom today. You get to ask questions too. So just enter them in the Q&A section on Zoom, and somebody's going to bring those questions up to you. So you are very much included in today's event. Let's see. Now it's my honor to introduce Simon Melov. What can I say about Simon? He is a hoot to work with. I've just had the pleasure of working with him for many years here at the Buck. He was one of the first hires here at the Buck. He is among the most collaborative of our faculty. That gives him a breadth of knowledge across all aspects of the aging process. The guy loves technology and has been instrumental in bringing state-of-the-art genomic and computational technologies to the book. Plus, as you'll know, he is into exercise. I first became aware of this back in 2007 when he published an attention-grabbing study that showed that basic weight training, just strength training in older adults, literally reversed the genetic fingerprint in muscles to that of a younger person. Pretty exciting stuff. And he's gone on from there. So Simon, up to you.
Thanks, Chris. Well, wow, this is a pretty full house. So thank you again for all turning up for this seminar. So I'm going to kick this off with a couple of basic questions to you all. So first of all, who has exercised here this week? Hands up. Okay, thank you. Good night. Okay, now here's a question to winnow things down a little bit into the real hard achievers. Who here has exercised today? Well, I think that's more than 50%, Chris. No, Robin says no. Okay. All right. Okay, so I'm going to start this off with actually a little diversion into some projects in my lab which show you some of the sort of diverse approaches which we can take in investigating basic processes of aging. And exercise is, of course, one of the main sort of paradigms which is being globally pursued to forestall many of the degenerative changes associated with aging. And we'll talk about that extensively in a little bit. But to start with, I'm going to bring up these couple of organisms here, which on the face of it, you would think they don't really have much to do with each other. One is a honeybee, and the other is a whale. Now, what might unify these two really, really different organisms? Well, they're both examples of extreme longevity. The honeybee has a very interesting biology whereby the queens live much, much longer than the drones, and the whales live very, very much longer than you would predict based upon a number of things. And so we wanted to sort of look at why whales might be a good model organism for aging. And part of this came about through some really interesting discoveries about jade harpoon heads, which were found embedded in the flesh of some bowhead whales, which are harvested routinely in Alaska as part of sort of the Native American culling which they have there. And there was a lot of confusion initially about how these jade harpoon heads could be inside these animals because they hadn't been used for hundreds of years. It turns out that those animals do in fact live for hundreds of years. And so bowhead whales now have been legitimately dated as living for over 200 years. They may live more than 300 or 400 years. We're not sure, actually, because it's pretty difficult to get the clinical birth certificates of whales which are living that long. So other whales also have very long lifespans, some in excess of 100 years, but again, the data is pretty scarce, it's sparse, for all of the obvious reasons you could imagine. And how can you study whale aging in the lab? And this is the real crux of it. I can tell you that the cage costs are a bitch. So if we're not going to catch whales, what might you be able to do? And there are some examples of what you can do here. So this is a beached blue whale, which actually happened not so far from here a few years ago, actually. And this is some drone footage taken of it, and it just shows you the scale of the animal. This poor animal was actually hit by a ship and unfortunately killed, washed up. And I saw this on the local news coverage, and I started thinking, these guys are really interesting. And we know that some species of whales live for a long period of time. Maybe I could go there and get some bits of tissue or bone or something and do something with. So that's in fact what I did. I went to Home Depot and got myself a whale necropsy kit, which was on special for $10.99. And this is me a few weeks later wading into the decomposing whale, collecting tissues and doing stuff. Now, I have some pieces of the whale. There's a whole interesting story about this, which I don't have time to tell you today. But needless to say, this interest evolved. I ended up having a collaboration with a biologist who routinely tags whales in the wild and actually obtains tissue biopsies from those whales. So we now have about 10 cell lines frozen down from humpback whales and blue whales in the lab upstairs in this building, and you could say we have actively growing whales in the lab. Now, turning to from the sublime to the ridiculous, we have the honeybee as well. Now, these guys also have very long lifespans for their size, and the queens live 30 times longer than the drones. If you were to translate that into human terms, you'd be talking about a 2,400-year-old human. So wouldn't you want to know why someone lived 2,400 years and everyone else lived 80 years? That's a pretty interesting question. They're also cheap. You can house thousands of them. So we have thousands of subjects here on the campus, and we can also mass culture queens. And the bee is also a very important organism for our overall environment for reasons I'm sure you know about. Okay, so here's these two very disparate organisms which we're attempting to glean insights into the biology of aging by looking at these mechanisms and what may be common between them and so forth. Okay, I want to turn now to something else which we'll discuss a little bit, but this is basically an alert to you all who want to participate in research yourselves. And this is a brand new study which is being run by Brianna Stubbs, who you will come to know over the coming months and years. And this is a study which is called MOVE, which we have launched, and this is a human study on aging and exercise. And MOVE stands for Molecular Optimization via Exercise. We want you to volunteer for this. Now, we can't take everybody, so it's competitive, okay? But we want to recruit you and understand better how exercise makes us healthier, live longer, and delay various conditions associated with aging. Now, this is a very busy slide, which is outlining a lot of the features which we're doing in this study. But we're going to take muscle biopsies from people who volunteer for the study. We're going to measure everything in these people, like a huge amount of different molecular readouts. We're going to look at mitochondrial function. We're going to look at a whole array of different metrics and then try and contrast people who exercise moderately, which will be some people in this audience, versus elite athletes. Now, those elite athletes have astonishing physical parameters which distinguish them very, very dramatically from a quote-unquote normal person. And so we're hoping to understand what is different at the molecular level from these elite athletes versus the non-elite human specimens, which would be people in this audience. Some of you may be elite athletes. I should say elite older athletes. So we're interested in people over the age of 65. So that's MOVE. So you can find more about that at the QR code and submit your interest there. Okay, so now turning to the main topic here. Now, we're going to start this off with a little bit of background, and then Chris and I will discuss this in the context of questions and sort of what is the state of knowledge about exercise and aging and longevity and so forth. But I want to start this conversation out with the following slide. This is how our ancestors lived. They basically walked a lot, they moved a lot. The estimates are it's something like 18 miles a day our ancestors were moving. And if any of you have walked 18 miles in a day, that's a fair amount. That's more than 10,000 steps, okay? So our whole physiology is geared towards moving and activity. That's what all of our genes were selected for in terms of maintaining optimal health so that we could make those movements. We could venture forth into the savannah, we could hunt, we could bring back supplies to our non-exercising people who are back at the camp and so forth. But this is how our whole sort of physiology is geared towards being. It expects this kind of commitment on an individual level. Now, if you don't have access to fast food, if you don't have access to a supermarket, if you don't have access to purchasable food, you have to go out and get it. And that is a major incentive to move. Now, if you remove that incentive by supplying fast food, by supplying easily available foodstuffs to maintain your body on a day-to-day basis, guess what happens? Your body starts going, this is kind of strange. Well, maybe we'll just start storing away those calories for future droughts and future famines and so forth. And so pretty rapidly, people begin to put on weight as a function of lack of movement. And globally, this is happening at an astonishing rate. It didn't used to be the case 50 years ago that obesity was a major problem. But now it is a major problem, which largely comes about through inactivity and a sedentary lifestyle. So we really did evolve to move. And there are a number of things I'm going to say here which will be sort of obvious to some extent, in that exercise is known to be good for you. And I think most people here, given by the raise of hands earlier, understand this message. But nevertheless, it is really, really important to do this on a regular basis. This is not new information. This information we have had for a very long time. What is starting to happen now is we're beginning to understand the molecular mechanisms which drive the beneficial effects from regular exercise. And being sedentary is really bad for you. I'm sure many of you have seen headlines in various publications about how many hours a day people sit and the negative consequences from sitting for long periods of time and so forth. But this is an evolving area which actually is slowly resulting in a consensus about how much activity is good for you, what types of activity you need to do in order to maximize your benefits. This has been a very slow-moving train because there are a wide array of activities you can do which are considered exercise. And it's been difficult to nail down what is the optimal program for each individual, how much the programs vary across individuals in terms of their efficacy in promoting health, particularly in the long term. But it's slowly being worked out. There's an evolving consensus about you must mix this up. You can't just do one thing. You must do resistance training, strength training. You must do endurance training. And of course, the old maxim, something is better than nothing, holds absolutely true. So if you can't do one thing, you do another thing. If you can't do that thing, you do yet another thing, and so forth and so forth. So it's a very, very global phenomena in terms of our understanding of the benefits of regular exercise, but the molecular transducers of it are still sort of being worked out. And one of the major programs for this is something called MotorPack. Now, MotorPack is a major effort underway which was sponsored by the NIH, and this is from their webpage. And MotorPack actually stands for the Molecular Transducers of Physical Activity Consortium, which is just rolls off your tongue. It's just like, that's the first thing I thought of when I heard MotorPack. I thought, oh, that's easy to remember. What does that stand for again? Anyway, the point is this has been underway for about 6 years now. They enrolled a large number of young people, mostly. They didn't have an emphasis on aging. They had an emphasis on just trying to understand, why do people feel good after exercise? Why are there benefits to regular exercise and so forth? And so they had multiple sites funded. It's a very big, well-funded program in excess of, I think, over $400 million now they've spent on this. But it's a very, very expansive program, and it is slowly but surely identifying the molecular players which drive the benefits of regular exercise. And you can go to this website for more of that. And I think just to read this, the program's goal is to study the molecular changes that occur during and after exercise, and ultimately to advance the understanding of how physical activity improves and preserves health. This is a thing. This is happening, okay? And I'm sure many of you have questions about the exact amount of exercise, what types of exercise. I heard about this study, I heard about that study, and so forth. And so that's what we can engage in here today, that kind of a conversation. So with that, I think we can move on to the The dialogue.
They're the dialogue.
Yes.
So now it's time for you to participate. If you have questions, please write them on your note card, raise your hand. We will get to them, and Simon and I are going to sit down and we're going to have a conversation and include you in it. So Simon, my first question for you, since you talked about the molecular benefits, I want to get people here even more motivated to exercise. So why is exercise good? Give us some examples.
Sure. So I think who here has heard of Peter Attia? Okay.
Peter Attia.
Peter Attia. He's a medic who has a very popular podcast. If any of you are interested in the deep science behind longevity in general, he has a great podcast which you can listen to, which is called The Drive. So if you're interested in podcasts with like a deep dive into the science behind the benefits of various different aspects of aging and what's driving aging, then I can thoroughly recommend that. Anyway, he calls the 4 major areas which are driving healthcare costs in the US, the 4 horsemen of the apocalypse: cardiovascular disease, cancer, neurodegenerative disease, and metabolic disease. Those 4 conditions basically drive healthcare costs in globally now, and exercise has been shown to promote both the decrease in the incidence with each of those areas, as well as slow the progression in each of those areas. And you might think something like cancer might not benefit from exercise. I mean, I think everyone can kind of intuitively understand to some extent the benefits of regular exercise in cardiovascular disease, and certainly with regards to obesity and diabetes and things like that. Again, it seems a little bit intuitive that you could see why exercise would be beneficial in terms of those 2 conditions. But neurodegenerative disease and cancer, not so intuitive. However, people who exercise regularly will slow the progression of the disease. That is absolutely true. And just FYI, I was diagnosed with Parkinson's about 5 years ago. And since then, I've been regularly exercising because I know the literature. The literature says that if you regularly exercise, you will blunt the progression, you'll blunt the progression of symptoms and so forth. So it's something which you can take home to the bank in any one of those conditions. Those 4 conditions or 4 areas of disease are all equally affected by exercise in terms of slowing their advance, reducing the incidence, and so forth.
Great. Getting great questions. Just want you all to know that we will be sending out the QR code to you, or we'll send an email to give you the name of that podcast. So don't worry about having to remember that stuff. We'll take notes and we'll be sending you that information. So, Simon, people want to know, is there a best exercise? And how does somebody determine what the best exercise is?
Yeah, sure. So this is a common question I get a lot, and I think most people who are in the field of exercise and aging often get, what's the best exercise? What's the best exercise? Well, the best exercise you can do is, it's a little bit like photography in a sense that the best exercise you can do is the one you have or the one you can do. So sometimes people will say, well, I have arthritis, I can't do running, or I have some other condition which precludes me from doing this particular exercise which I read about. Some activity is better than no activity, absolutely. So if you can't do one thing, do something else. That is absolutely true. But there is an emerging consensus, as I alluded to earlier, about 2 types of exercise which you should do on a regular basis to optimize your exercise budget. Now, we can talk about exercise budgets. All of you, or pretty much all of you, I think, put up your hands earlier when I asked about the exercise frequency. But along with that, you have an exercise budget. And that means how much time can you spare to exercise per week. Let's say let's be generous, let's say it's 10 hours a week you can exercise, which would be a lot for most people, particularly with full-time jobs and so forth. But if you have 10 hours to exercise, then you would want to split that into different types of exercise. You don't want to do 10 hours of running a week. That's going to be beneficial to you, but it won't be beneficial to a maximal effect. So you would want to split that into probably about 70 to 80% of what's called zone 2, which means a very moderate increase in heart rate, but it's fine-tuning your mitochondria. It's fine-tuning the sort of powerhouses of your body in terms of optimal function. And then about 20% of that you would want to do in high intensity, so that is something which some of you have heard about, I'm sure. And then you also have to put in there somewhere weights as well. You also have to do resistance exercise. So your budget has to be composed of those kind of 3 areas. That is reflective of where the literature is going in terms of optimizing your outcomes on your overall longevity and your resistance to diseases and your optimal function for daily living.
So I'm getting a lot of questions from folks who have arthritis and are wondering, like, do you have any workarounds? Like if people have bad knees, bad hips?
Yeah, so the thing which aggravates arthritis, and I think those of you who suffer from it know, is impact. So you can't do impact stuff. What you can do is stationary stuff, so stationary bicycles and so forth. So stationary bikes are people who suffer from arthritis' friend. So it's something which you should be engaging in. Zero impact associated with it. It stabilizes your quads, it stabilizes your hips in terms of those joints, and will promote beneficial effects and outcomes on the progression of the condition. There's some evidence to suggest that if you can tolerate it, mild impact will also be beneficial. But it really depends on the individual and should, of course, be carried out in conjunction with your doctor's advice. So.
That's great. Somebody who has a scientific bent, can you elaborate on the role of glucose and insulin regulation yes.
Yeah, so one thing which we know about glucose is it's not good for you. This is one of the things which there's a great book on exercise and health in general called Exercised, E-X-E-R, whatever, E-D, Exercised, and it's by a physiologist at Harvard who visits the Hansa tribespeople who, was a picture I showed earlier of a Hansa tribesperson. He goes into some detail about what happens when you have a lot of glucose in your system, particularly prolonged exposure to glucose from fruit juice, from desserts, from candy and so forth over your life. It's shocking what will happen to your vascular system with these continuous spikes in glucose concentration. There's been autopsy studies on people in their 20s who have got atherosclerotic lesions in their vasculature, even in their 20s, purely from the diet and lifestyle. So this is something which can build up over a period of time, eventually result in frank disease, which will have a major impact on your quality of life. And it's very difficult to reverse that once that's started. But there are real consequences to having high levels of glucose in your diet and your bloodstream over prolonged periods of time. And atherosclerotic disease in general is a very bad thing because it triggers other things, and those other things are also very bad. So in general, you should try and consume glucose in ways which are not going to spike you. And there's a whole emerging area of technology in this regard. I'm wearing a CGM right now. CGM stands for continuous glucose monitor. I don't have diabetes, but I'm interested in monitoring the glucose in my bloodstream on a fairly regular basis. It's a little bit of a simplification to say I'm measuring it in my bloodstream, because it's not really measuring it in my bloodstream, but that's a technical issue. The fact of the matter is, every time I eat something, I can see what happens to the glucose in my body, and it goes up like this, and then it comes down. And then when you exercise, it goes down like this. So you have a meal, you go out for a walk, your glucose levels will do this. You have a meal, you sit down, you have some candy and stuff like that, and your glucose levels will continue to do this. And there are consequences, as I said, to doing that repeatedly over time. Every now and then it doesn't matter, but if you're doing this in, day out, and having these spikes of glucose in your bloodstream, there will be consequences to you in the long term. And so this is something which we're understanding more and more through these wonderful devices which are now being personalized and sold in the market. And as I said, I have a CGM right here, which is telling me, I can look at my phone at any given time and it'll tell me what the glucose level in my body is. And so I know, ooh, don't have that donut. You know what happens when you have a donut. So it's a real-time readout, and I can't stress enough the benefit of having feedback to yourself, which is objective. It's not somebody telling you, don't have a donut, don't do this, don't do that, which you can go, whatever, you know. But when you see what happens when you have a donut, it's very, very different than having someone tell you it's bad for you. So anyway.
We got a couple questions, more than a couple questions, related to muscle mass. So what happens with muscle mass as we age? And then somebody says, I'm over 70. Is it too late to begin building strength in my arms? I'm a daily walker, but feel my arms are getting weak. So muscle mass, exercise.
Let's start with the last question first. So it is never too late to start exercising. There are multiple studies for resistance training in particular, and we can talk about endurance training later, but multiple studies for resistance training which have been done on people in their 80s, people in their 90s who've never exercised, and they put on muscle mass. So you can put on muscle mass, doesn't matter what age you are, and there will be benefits to doing that. You should absolutely be doing some kind of resistance training, especially once you get over the age of about 50. And it's particularly important for women because it slows the potential bone loss, which can lead to osteoporosis, but it's also important for men. We begin to lose muscle mass due to the aging process somewhere in the 40s to 50s, and you will lose about 1% of your muscle mass per year, unless you're actively working to prevent that loss. Now, you can't stop the loss entirely. So I just want to be clear about this. It's not as though if you exercise regularly and you do resistance exercise on a regular basis, you will not lose muscle mass. You will still lose muscle mass, but the rate of change will be like this as opposed to like this. So you want to change the slope. That's what you want to do. Muscle mass loss becomes increasingly larger in its magnitude on an annual basis once you hit your 70s and your 80s. And I think most people who are in their 70s and 80s will, in reflective periods, be thinking about themselves going, well, what happened to all my muscles? It seems to have gone over the last 30 years or so. If you look at yourself as a 30-year-old and you look at yourself as an 80-year-old, there is a big difference, okay? Now, everyone knows this who has reached 80. I think even at younger ages, you'll think of yourself in that way. Film stars are also a kind of an interesting exercise in this regard. I mean, you can look at someone like Sylvester Stallone, whose body shape and type has been documented very extensively over his entire life. Now, he's in his mid-70s now, and he is fighting hard to try and wind the clock back with everything which he can throw at it. And even then, he's still losing muscle mass. So it's something which is to some extent inevitable, at least at this point in time. It's not always going to be the case because there are multiple efforts underway to try and reverse this pharmacologically by understanding the basis for the muscle loss. And we have a program in my lab where we're working on that. There are some really exciting technologies and tools coming down the pipe which will help us understand this much better. But you must maintain your muscle mass by regular resistance training, because if you do not, People who are weak are more prone to fall. If you fall, you're more likely to break something. If you break something, you're more likely to end up in hospital. And this can be a very, very fast downward spiral. So keep that muscle mass. Don't stop exercising.
We got some questions about diet. A lot of people at the Buck and overall intermittent fasting is a very big deal. So people want to know about fasting and exercise, how they should handle that. Protein intake. What is your opinion on protein and exercise?
Yep.
How do we need more protein?
Yep.
And as a 50-year-old female, do I have to eat prior to weight training, or can I train fasting? I heard that men and women may react differently.
There's a lot of literature which is a little bit contradictory in some of these areas, and this is one of the reasons why it's been so confusing for the general public to figure out what they're doing on a personal basis. With regards to diet and weight training, it's true you need to increase your protein intake as you get older. I'm sure most of you have heard that from your doctors, and there's some general recommendations for this. You should definitely increase the amount of protein you take on a daily basis as you get older. Someone in their 30s has a very different protein requirement than someone in their 80s. And that may be due to some maladaptive processes occurring in us which are impairing our ability to take up protein. So you need to take more protein in order to get the protein you need to maintain your muscle mass. So first, that's number one. You need to increase protein intake as you get older. With regards to fasting, that is actually, there's a lot of literature now suggesting that is beneficial. And that might come from caloric optimization. In general, people consume too much calories. Again, this is not shocking to anyone in this audience. If you look at the average weights in America, you're getting this over the last few decades. They're just going up and up and up and up, so much so that airlines have had to change the seat sizes, cars have had to change their seat sizes, and so forth. But intermittent fasting is more like what the Hansa tribes people are doing. They're doing that because they don't have access to ready calories. They have to walk long distances to get their food. So they are already optimized. And so the intermittent fasting may really reflect more of a native state for us. This is reducing the number of calories you take so that you can optimize your physiology. It's not that there's something magical about not eating every other day or eating in time-restricted feeding windows or something like that. That's what we evolved to be. We didn't evolve in this calorie-rich environment where we were just like drowning in enormous amounts of calories on a daily basis. So this is something which I think is more geared towards being nice to your body and like saying, well, this is what you really want, isn't it? Which is less. So I think that there's some scientific rationale behind intermittent fasting and fasting in general.
Any advice on what we should do pre and post heavy exercise?
I don't think there's anything particularly robust with regards to giving some recommendations in that regard. And the only thing which is important to stress as we're talking about this as a general subject is you can do too much of anything. So you definitely want to have adequate rest periods between your exercise periods. So you don't want to, be training for a 100-mile marathon and then go and do 400 set reps of 50 kilos or something. It's you can do too much of anything. So rest is also important. I mean, I'm sure you all know sleep is important. You've got to have good sleep. So the idea is to mix this up in a way where your body is maximizing the benefits of all of the things you're doing, and you're not shortchanging your body in some regard or another.
So somebody asks, how much is too much exercise? How do we know? Somebody also is curious about motivating couch potatoes, and I am wondering your take on personal trainers. Like how, do you have any opinion about that as far as can that help?
Well, the personal trainer first. if you can afford a personal trainer, go for it. You know, I mean, it's great to have someone assisting you on a daily basis or a weekly basis, which will incentivize you. There's a lot of discussion about incentivizing people to exercise. Personally, I think, you know, these sorts of things, electronic fitness trackers, watches. I wear an Apple Watch. A Garmin is also very good. These things are kind of like a personal trainer in some ways. They can give you a lot of feedback about what you're doing, how well you're doing it. They can remind you and so forth. So they're kind of a little bit like a personal trainer. But if you can actually afford an actual personal trainer and on a regular basis, that's even better. I forget the first few questions.
How do you know if you're exercising too much?
Well, that will be, again, sort of a personalized response. Your body will go, ow, you know, and you'll go, well, I've got to put in my weight training because my calendar says I have to do the weight training, ow, you know, so that means don't do it, okay? So listen to your body. In general, you know, too much, there's again a mixed literature on this. I mean, there are papers in the literature showing people who even run a single marathon do damage, you know, so there's some controversy about what is permanently damaging versus, you know, transiently damaging and so forth. Certainly, I think there's I would say a moderate consensus that ultra marathons and sports like that are not good for you. That doesn't mean, you know, if you can do an ultra marathon, great, but I mean, it comes at a cost. So those sorts of things where there are huge burdens on the body, because I mean, we're not really designed to run for 100 miles. You know, there may be negative consequences to too much of that sort of thing.
What do we know about gender and exercise, differences between males and females?
Well, one of the things which I talked about earlier is osteoporosis and resistance exercise. It is particularly important for women to begin resistance exercise in their 40s and 50s, you know, with the onset of menopause, because that's when the bone loss starts to accelerate. And because women have less bone than men, that's just a gender thing. Like if you take young women, you take young men have much more bone mass than young women. And so the onset of osteoporosis in men is typically older than women. Doesn't mean that because men don't go through you know, menopause that they can't develop osteoporosis. There used to be that school of thought of, you know, quite a few decades ago that men somehow didn't get osteoporosis. It turned out, yeah, they do. They just get it later. And that's largely because the bone in a male is more than in a female, and so if you're losing it at the same rate, the women will begin to develop osteoporosis before the men. So, but there are multiple exercise programs now and really terrific data in the literature which shows that resistance training can blunt or even completely prevent osteoporosis in women. There's several really good programs I saw actually in Australia, as one clinic there has particularly good success in slowing or even reversing osteoporosis in women you know, who are adhering very strictly to a good weight training program.
So we got a few questions about supplements and drugs. Are there any supplements that enhance the effectiveness of exercise? Somebody wants to know about NAD+, which is a pretty hot topic. And then what about using anti-inflammatories, like before or after exercise?
Yeah, the literature on this is mixed as well. It's difficult to make any statement which is sort of like you can take home to the bank here. With regards to supplements in general, there's an enormous market in the US for supplements. I mean, it's a multi-billion-dollar market. There's lots of claims made about these things, but very little of it is rigorous or you know, field tested to the extent you could take it home to the bank. There are a few newer interventions which are classed as supplements, but actually have some good clinical data associated with it in people beyond animal models. I'm talking beyond, mouse studies or worm studies and so forth. And those are with regards to enhancing mitochondrial function. And this is something, the product is called MitoPure. There's an array of products which are built around this concept of boosting repair of mitochondria without getting too much into the technical details of it. And this is derived from sort of extracts from pomegranate juice. This is sort of how this whole sort of story developed. But that has some good clinical data supporting that, which show that you can actually improve function in older individuals who've been taking these supplements for a few weeks. There are also a few studies like that with other supplements, but the actual sort of field-tested area of supplements with age-related conditions and aging in general is more a field of failure than success. So it's difficult to give you anything sort of more concrete than that.
And how about taking anti-inflammatories, like as a pain preventativeness before you exercise?
Yeah, sometimes these things might blunt the beneficial effects of exercise. So there's some evidence to indicate that you should not take anti-inflammatories, post-exercise to get rid of the pain, because that will actually interfere with the beneficial effects of exercise. It's a little bit murky. It's not solid, and so that we know exactly that this is the case. But in general, if you have to take anti-inflammatories to exercise, probably means you're doing something suboptimally, or you should do something where you don't have to do that.
We got a couple questions about Parkinson's, about how does exercise impact Parkinson's, and are there particular exercises that are recommended?
Yeah, so this is an exploding literature. When I developed Parkinson's, I dived deep into literature and found that there was this emerging concept that exercise was good for Parkinson's. So it was the same sort of question which we just got: what type of exercise? How often? What do you do? And so the emerging literature on this is that you should do some kind of HIIT. So who knows what HIIT is? Ooh, pretty good, like 50%. So HIIT stands for high intensity interval training. It's actually developed from Olympic training, mostly from Scandinavia. I think it's far back as the 60s, actually. People were doing interval training to improve athletic performance in various track events. But what it means is, like if I give you a 4x4 protocol, like a 4x4 protocol would be, it's a little bit funny wording, but a 4x4 protocol would be 4 minutes of sprinting. Sprinting could be, and it doesn't mean like literally, like Carl Lewis type sprinting or something like that. It means going pretty fast so your heart rate goes up, right? And then 2 minutes of rest, then 4 minutes of sprinting, 2 minutes of rest, 4 minutes of sprinting, 2 minutes. You do that 4 times, that's a HIIT, okay? So you want your heart to go like this. You want it to go up, down, up, down, up, down. And you can actually just walk in your 2 minutes. But you should be elevating your heart rate to 80% of your maximum heart rate. Now, most of you may know that your maximum heart rate is supposed to be 220 minus your age, right? That's probably not correct, and many of you can figure out what it is from a watch or a chest strap monitor or something like that under supervision from your doctor, as long as they tell you, yeah, it's okay to try and find out what your maximum heart rate actually is. But the 220 minus your age is likely to be conservative. So if you want to know what 80% of your maximum heart rate is, find out what your maximum heart rate is. So that will be what you're trying to get at. You're trying to hit like this peak here, and then you come down here, and this sort of practice is called HIIT. So that is beneficial for people with neurological conditions, AD, PD. There's multiple studies have shown that, as is so-called Zone 2 training, which I talked about earlier. So you should be mixing these things up on a regular basis.
What's the correlation between longevity and VO2 max, which you just mentioned? So
VO2 max, we tested here at the Buck. So VO2 max is an excellent predictor of your longevity. It's as good or better than walking speed, which is another well-used metric. As you get older, you'll find your walking speed tends to slow down. There's been huge studies looking at this in terms of the amount of decline in your walking speed relates to your eventual lifespan. Similarly with VO2 max, people with high VO2 maxes typically will live longer. And the reason for that is VO2 max represents how efficiently your body can use oxygen to perform work. So people who can perform work, i.e. exercise, more efficiently than another individual will have a higher VO2 max. Now, professional athletes will often have VO2 maxes, just to give you some numbers here, in the 70s and 80s. This is like, they're like a different species. Like most people in this audience here will have VO2 maxes ranging at a very low, probably 20 something. That would be because we've got some older folks in the audience. Your VO2 max goes down as you get older. Now, if you're very fit, you'll be above 45, 50, and then if you're extremely fit, there's one individual in particular I can think of at the Buck who's probably going to have a VO2 max of 60. That's very fit. Okay, but once you hit 70, you're pro level, right? Now, if we have any in the audience has a VO2 max in excess of 60, raise your hand. Oh, all right. That's fantastic. Can I ask how old are you?
65.
65 with a VO2 max of what?
It was superior, though.
Oh, is this on a watch or is this actually measured in a clinic?
In a clinic.
Well, we don't worry about the superlatives. So more than 60 though?
Yes.
That is very good. So this woman deserves a round of applause. It's outstanding. That is a very good predictor of your longevity right there. Okay, but you should let everyone know they're not easy tests to do, are they?
No, it was walking like a treadmill, at high speed and at elevation.
Yep.
So,
Yep. And then you also have to wear a mask, right?
So yes, mask.
Yeah.
And it was a couple years ago.
That's it.
Maybe 3 years ago.
Okay, well that's still well done. Well done.
So what's the bet? Is aerobic exercise the way that you build
Endurance,
up?
yeah, so typically runners or people who do a lot of endurance exercise will have high VO2 maxes. People who weightlift will not typically have high VO2 maxes, although you can build it. Your actual upper set point is largely genetically determined, but you can build your VO2 max. You can train your VO2 max for sure. You can start at like 40, and then you can say, I want to see if how high I can get it. But there are programs to build it. Many programs on the web you can look at to build it. But your watch, your fitness tracker, and the only two I'm really familiar with is Apple Watch and the Garmin watch. They will both estimate your VO2 max as long as you're outside running. You have to do some kind of running for, I want to say it's like 15 minutes or something like that. But you need to do that in order to estimate the VO2 max. It's not as good as measuring it in a clinic. Like if any of you enroll in our MOVE study, you will get your actual VO2 max measured here. In fact, we're just having the machine installed this week to measure it. And several of us are going to be measuring our own VO2 maxes on a regular basis. And so, yeah.
Is playing sports considered exercising?
Absolutely. Not chess, but most sports. Yes.
If you had to choose, people are asking, if I have to choose between exercise or sleep, which one is more important?
Ooh. Okay. This is called the Sophie's choice of exercise physiology. So we don't answer those kinds of questions. You need both. You can't kill one or the other. You have to exercise and you have to sleep. It's like, what am I going to do? Not sleep? Well, maybe, but you should definitely sleep. There are multiple studies showing, for example, airline pilots who routinely change time zones, and they have trouble sleeping because they're changing time zones all the time. That has an impact on their health. So don't neglect sleep.
Got it. Joran, I forgot to move the slides forward. Can you put the next slide up there? Because I want Simon to talk again, or I can get the clicker. If you can, there you go. So once again, go over what's going to happen in this clinical trial so folks know. If you can't get the QR code today, don't freak out. We're going to include that in an email that you're going to get.
Yeah, so this is one of the ongoing clinical studies which we have at the Buck now, where we're going to be recruiting a group of older adults who are, in good health. We don't want you to be in bad health. We want you to be in good health, and we're going to perform a whole array of tests on you, state-of-the-art tests, which nowhere else in the world can you get this array of tests done on you except here at the Buck. And then we are going to use that data and compare it to a group of elite older athletes and see what makes those people so special. What makes them able to have like VO2 maxes in their 70s and 80s? There are older individuals who have that level of VO2 max and these performance characteristics and so forth. There's some magic there in the translation of the exercise into molecular players internally which impact your overall health and reduce your risk of age-related disease and so forth. We want to know what that is because arguably that is druggable. That is some approach where we could potentially get some of those benefits. I don't think there'll ever be a pill for exercise. I don't think that's... Anyone who tells you that was probably, there's a little bit, like this. But I think it's quite likely we will find drug interventions which will confer some of the benefits of exercise. And that's going to be important to a big fraction of the population who just cannot or will not exercise. We've got to get these healthcare costs under control, otherwise they're going to bankrupt the world within the next few years.
I also want to point out that we have other clinical trials happening at the Buck. They're on our website. If you look at the program, Brianna Stubbs is going to be doing a session in the future. She is the one who knows all about all the clinical trials that were here, so make a note to come to that one and check out the info that is on our website. Joran, can I have the final slide up? First, I want to thank Simon. He's great, right? He's a hoot, right? So I want to thank all of you for being here today. I hope you enjoyed this as much as I did. So as I mentioned, here's what's happening next. You're going to get an email with a link to today's event, so you can watch the video again if you want to, and it will have information about clinical trials and some of what Simon talked about today. The email will also include instructions on how to register for our next community seminar. On May 1st, I will be talking with Dr. David Furman. His subject, What Can Outer Space Teach Us About Aging? I've written some news releases on this program. It's fascinating stuff. It'll be a good session. So if you are new to the Buck, please come on a public tour. We do them on Tuesdays and Thursdays. And you can also sign up for our newsletter. All of that happens on our website. The second season of our popular podcast called We're Not Getting Any Younger Yet drops today. So we're starting our second season. The first guest is Laura Karstensen, who is from the Stanford Center on Longevity. She's excellent. It'll be a great listen. And you can go back to the first session. We really do talk to leaders in the field, and if you're interested in healthy aging, it's a good one to check out. And then finally, I very much encourage you to become a donor and become a partner with us in our efforts to help all of us live better longer. Your gifts here make a difference. Simon talked about his honeybees. That project was funded by our popular donor group. So when you give money to the Buck, you are furthering this really important science. If you're interested in ways to get involved or you want more information, there are folks here from our philanthropy department. Brian, Heather, Lisa, raise your hands. They are here. They're happy to answer your questions after the event. Once again, I will be here on May 1st. I hope you will be too. Thank you so much for coming. I really appreciate it. Have a great day. Everybody, how many people are going to go on an extra walk today? Anybody going to go on an extra walk today? You bet. Thank you, Simon.
Sure.